Alright, hello virtual learners. Mrs. Step is back here. I got a new how-to video for you guys today. Today's all going to be about how we can build number sense or numeracy and number relationships by playing the game Changing Numbers. This is a game I play often with kindergarten and first grade students. However, I also play this game quite a bit with students that are in upper grades that somehow miss this skill along the way. It's very, very important, but it's not always as explicitly written out in grade level standards as it could be. So let me give you a little background knowledge about the skill we're trying to build here. So when students understand that numbers are made of parts, for example, 5 is not just 1, 2, 3, 4, 5, but 5 can also be thought about 1 and 4 because there's a 1 and a 4 inside of 5, or it can be thought about as 2 and 3, or 2 and 2 and 1 more. So when students understand that there's smaller numbers inside of larger numbers, they're going to be learning how numbers are connected, how they relate to each other. When they do start to make those connections and they learn how numbers are related to each other, there's going to be no need for all of this memorization, so killing your kids with flashcards until they cry because they can't remember all of those facts. There's plenty of kids like that. I was like that when I was little. There will be no need to memorize because they're going to be able to make those connections. So if they understand things like 2 and 2 makes 4, then when they have to do 2 and 3, they can see 2 and 2 is 4 and 1 more is 5. That's what I'm talking about when I'm saying make those connections. It's way more fun to teach using connections, and the most important thing is that it's building number sense in students, okay? So knowing how those numbers relate to each other, that's a prerequisite skill for any computation strategy. If you're going to be doing computation with understanding, that includes addition, subtraction, multiplication, and division. You want to understand that how to break down numbers, and that easier facts can help you with harder facts. The basis for all of that is understanding that there's numbers inside of numbers. So this is a huge prerequisite skill, and it also helps greatly with understanding comparison problems. I'm going to model that for you guys today. Comparison problems are just problems that compare quantities. They might ask questions like, there's 7 red fish and 4 blue fish. How many more red fish than blue fish? Or how many fewer blue fish than red fish? It might say something like, Kai has 5 M&Ms and his friend has 3 more than him. How many does his friend have? Or Kai has 5 fewer than his friend. If his friend has 8, how many does Kai have? These questions, the comparison problems, are typically tricky for a lot of our students. And the reason why it's tricky, in my experience, is because students do not have enough experiences changing numbers and seeing how numbers relate to each other. So for this game, all you need is a game mat that you can make super easily. You can either use a 10 frame or 10 dots grouped as 5 and 5. And you don't need a number generator, but it makes it more fun. Here's some sample number generators. You can use a regular dot dice. You can use a dice that goes up to larger numbers, or you can use dominoes or any kind of representation of a number. And you need some type of manipulative. So you can use anything that you can find in your house, like goldfish, pasta. I'm just going to use the goldfish for today to be my manipulative. All right, so to start the game, let's just say I'm a kindergartner and I'm starting this. So I'm going to roll, and I see 4, so I'm going to create a set of 4. So you might have a student create a set of 4 like this. If they're looking at 4 like this, eventually they might start noticing, hey, if that's 5, 4 is 1 less than 5. Or they might set up their 4 like this and say, oh, 2 and 2 is 4. It's also cool if we do 3 and 1 is 4. See all that they're learning just about 4 there? So say you rolled 4, and so now it's time to change that number. So we're going to roll again. So now I want you to change 4 to 3. Now what students will do if they do not understand how numbers relate to each other is they will take all 4 of them off, and then they will count out 3 more. But what we want them to get to do is see how they can use these number parts to change 4 to 3. So as they practice more and play more, they will realize, hey, I only have to take 1 away from the 4, and now I have 3. So they're learning that relationship between 3 and 4. 3. Oh, that's the same. Let me roll again. 6. Okay, so I have 3. How do I make that 6? So do I need more or fewer? Well, I need more. 6 is bigger than 3. So I can think 3 and count on 4, 5, 6. Okay, how many more did you need? Well, I had 3 and then 3 more made 6. So 6 is 3 more than 3, or 2 3s make 6. You roll again. 1. Ooh, okay. Am I going to have to take off fish or put on fish? Well, I'm going to have to take off fish. How many fish do you think I'm going to have to take off to get to 1? Give them some think time. I'm going to have to take off 5, and then I should be level 1. Okay, go ahead and check. And let them go ahead and check and see if they were right. How many fish did you have to take off? I did. I had to take off 5. So now they're learning that relationship. 5 and 1 makes 6. Or if I have 6 and I take off 1, that would leave me with 5. Or if I have 6 and I take off 5, that would leave me with 1. So that's how it can work with the dice. If you want to amp it up a little bit, if you don't have a dice like this, you can easily create them. And if you don't want to have, if you don't have dice, you can use cards and just write numerals on them, or use a deck of cards, a regular plain deck of cards. Okay, so you just roll, and the only difference is here, this just goes up to higher numbers. And then if you really wanted to challenge them a little bit more, you could use something like dominoes if you have dominoes around your house. What makes the dominoes a little bit harder is that the dominoes actually have number parts on them instead of just one number. So they would have to first compose or put together the parts on the domino to figure out what number is represented on the whole domino. And then they can use that to play their changing numbers. So I might flip and I see 5, 6, 7, 8. So I need to change 1 to 8. How much more do you think I'm going to need? This is where we're going to have to count on. So 1, 2, 3, 4, 5, 6, 7, 8. Well, if I had 1, how many more did I need to get up to 8? 4, 5, 6, 7. So 1 and 7 more is 8. Or 8 take away 7 is 1. All right, let me try another one. Oh, 6 and 1 is 7. So right now I have 5, 6, 7, 8. I just want 7. Do I have to add fish or take fish away? Well, if I just take 1 fish away, that's going to get me back to 7. So I'm learning 7 is 1 less than 8. I'm learning how those numbers relate and how that can help me. It can help me immensely later on, because if I get a problem like 7 plus 8, and if I know 7 plus 7 is 14, I can add 1 more to get 15 for 7 plus 8. Or if I know like 7, if I know 8 is 5 and 3, then when I'm doing something like 8 times 6, I can do 6 times 5 and then 6 times 3. Or I can even do 8 times 5 and 8 times 1 and then put those partial products together. So you can see how foundational this skill is in any of the computation operations: addition, subtraction, multiplication, or division. This game is super, super powerful. All right, hope you guys have fun playing.